In this question, we have the market for sodas, and we have two events happening. Due to the new soda tax, people are moving towards consuming sparkling water instead, and also there was an increase in transportation costs due to minimum wage rising for truck drivers. The first event tells us that there's been a fall in demand, while the second event regarding the transportation costs tells us that there has been a fall in supply. So here's our answer to part A. We have a fall in demand and also a fall in supply. So we have simultaneous shifts of the demand and supply. Let's move on to part B. We're asked to graphically depict the changes in the market for sodas. And in this case, we're assuming that the fall in demand is greater than the fall in supply. Let's start out by drawing our axes first. We have quantity of sodas on the x-axis and price of sodas on the y-axis. We have a typical downward sloping demand curve and an upward sloping supply curve. And where these two curves meet is our market equilibrium, with equilibrium quantity marked with star and also equilibrium price. Now, since there has been a fall in demand, we're going to see the demand curve shifting to the left, and the new demand curve is the blue line marked as D prime. We're also going to see a fall in supply, so our supply curve is also going to shift to the left to the purple line at S prime. But as our assumption tells us, we're going to see a greater shift in the demand curve compared to our supply curve. Where these new demand and supply curves meet is our new equilibrium, where the blue line meets the purple line. And we have a new equilibrium quantity at Q prime and new equilibrium price P prime. And that new equilibrium is marked as EQ prime. Now, if we compare the new equilibrium to the old equilibrium, we can see that our equilibrium price is lower and our equilibrium quantity is also lower. In part C, we still have the same two events. We have a fall in demand and also a fall in supply, except in this case, the relative sizes will be different. Now we have the fall in supply being greater than the fall in demand. Again, let's start by drawing out our axes first. Our quantity of sodas is on the x-axis, price of sodas on the y-axis, downward sloping demand curve, upward sloping supply curve. Where those two curves meet is our market equilibrium, with equilibrium price and equilibrium quantity marked as P star and Q star. Again, we'll see the same shifts. Demand curve will shift to the left because there's been a fall in demand. Supply curve will shift to the left because there's been a fall in supply. However, when we draw these shifts out, since we're assuming that the fall in supply was greater than the fall in demand, your supply curve should shift to the left more than the demand curve. And where these two graphs meet is your equilibrium, with equilibrium price P prime and equilibrium quantity Q prime. Compared to the old equilibrium, we see that the equilibrium price is now higher and the equilibrium quantity is lower than before. In part D, again, we're doing the same exercise, except that we're assuming that the fall in demand and supply happened in equal amounts. Again, starting with drawing our axes with quantity on the x-axis, price on the y-axis, downward sloping demand curve, upward sloping supply curve, where those two meet is our equilibrium. We'll draw out our demand and supply curves again with a leftward shift, but in this case, the size of the shifts will be identical. Where the new supply curve meets the new demand curve is our new equilibrium. And we can see that the new equilibrium price hasn't changed compared to what it was previously. The equilibrium quantity has fallen. Then what is our conclusion based on our answers from parts B, C, and D? We see that in all three cases, our equilibrium quantity has fallen regardless of the relative size of the shifts. However, we see that we have a different result in the equilibrium price depending on which scenario we look at. In both cases, we saw demand and supply falling, which is the two events that had happened. But because we don't know the relative size between these two shifts, depending on the situation, we could either have our equilibrium price fall, rise, or stay the same as before. And this is happening because we just don't have enough information. All these three cases are possible just based on our information that there's been a fall in demand and a fall in supply. Hence, we can conclude that our equilibrium quantity of sodas in this market will fall. However, we cannot say for sure what will happen to our equilibrium price because we don't know which of these three scenarios would actually happen. So our equilibrium price ends up being ambiguous.